Okay, so just to look at this proof here and a bunch of these proofs, just to show you the general trend. They tell you here that basically that this angle right here, call it angle 3 and angle 6, are, or sorry, they want to prove that these are congruent. In order to do that, what they tell me is that T is parallel to H, so those are parallel lines. And that's what I write at the beginning here. I write that it's given, okay, that they're both given. I have to state what type of angles they are, though. And that's important. So in other words, I'm going to say here what angle 3 and angle 6 are. And the relationship is that they're alternate interior angles. And the reason always is that that's the definition of it. Whenever I'm telling what type of angles, that's the definition. So now to do this one here, just be aware here, at the end here, I can say, well, then angle 3 is congruent to angle 6. Because they're parallel, okay, and they're alternate interior angles, I can say that because of the theorem. If I go to the next one here, looking at it, very similar, but just a reverse. Now they're telling me, they give me that angle 3 is congruent to angle 6. I want to prove these lines are parallel. This is where I use a converse. Okay, so here, I'm going to use this as a converse and say, well, given that these are parallel, given that these two are parallel, I have to still say that they are alternate interior angles, and then I can use the converse to say that they're parallel. So it's just going backwards. That's why we call it a converse. I do the same thing with this one. 2 and 8, you'll notice are alternate exterior. So I tell you that, and then I can say they're congruent because of the theorem. Same thing here. The reverse. Now I give you that 2 is the same as 8. Tell me that they're parallel, and I can do that because of a converse. So it just goes back and forth. Just be aware of this. You'll see I do the same thing. Okay, 3 and 5 here, add up to 180. I have to tell you what type of angles, so I have to tell you that first before I tell you the relationship between them as a result of being parallel. Okay, so you'll notice I kind of go through a lot of these the exact same way. I'm going to jump ahead here to this one. And in this one, they tell me that these are parallel. Okay, so they're telling me that these are parallel lines. They tell me that 1 and 6 are supplementary. Okay, well, they don't actually tell me, or sorry, they want me to prove that 1 and 6 are supplementary or that they add to 180. This requires a little bit of work. I should recognize here that they are parallel lines, which means 4 and 6 should add up to 180 because they're same side interior. I got to get there somehow. What I do is I first tell you that 1 and 4 are the same. How do I do that? I first tell you that they're vertical angles. Then I can say, oh, by the way, they're the same because of the vertical angle theorem. Okay. Now I can get rid of, I'm pretty much done with 1 for now. But now I have here that 4 and 6 have to be, or pardon me, that they're same side interior angles. That's what they are. And that's just the definition of it. In which case, because they're parallel lines, 4 and 6 have to be supplementary because that's one of our theorems. That's actually the same side angle theorem. Now from there, I can get that measure of angle 4 plus the measure of angle 6 has to equal 180. And that's just a definition of supplementary. And again, I have to tell you they're supplementary before I use the definition. Last but not least, because we have this statement right here, I can substitute, instead of angle 4, I can put angle 1, and that's how I get this last statement. That's just a substitution property. You can go through a lot of these ones, and just to show you here, you know, very similar, that this is just kind of the reverse. Okay, and if you do the reverse there, you're going to get a converse at the end. So that's just a reverse of what we just did. Number 8, it's a little longer, but they want you to prove some relationship between 10 and 2. Well, they give you a bunch, there is no direct relationship, but there are relationships here. And I know that 10 and 14, let's say, are same side, which means they add up to 180. Okay, 10 and 14 should add up to 180. I also know that 10 and, or 2 and 14 are corresponding. And that's the route I took here. I first tell you that 2 and 14 are corresponding. Then I can say that they're equal. Why are they equal? Because they told me everything's parallel. Okay, that these two lines are parallel and these two lines are parallel. And so because of that, I can get that they're also that they're equal here. I can also get that 10 and 14 are same side, which means they're supplementary, which means they add up to 180, which means again that I can substitute and eventually get that anything that is equal to 180 when they add them up are supplementary, and that's just a definition. The last one here, very, very similar, but now they're telling me that 2 and 7 are supplementary. They want me to prove that these are parallel. Well, again, you could just jump into the fact that these are same side exterior and you'll be done. I took a little longer route to show you this. You can look at that, but I could have just said these are same side exterior and we would have been done that proof.